Good afternoon, class. Today what we're going to start is chapter 11, which is all about areas and perimeters of shapes. In particular, we're mainly going to look at polygons and circles. And we're going to be able to find the area of many different shapes by the end of this. You should already know what perimeter is from chapter 1, but we'll touch on that briefly also today. The first concept is there's three postulates that we're going to look at, postulates 24, 25, and 26. There's actually, I believe, only 3 more after this in our book, but these are essentially the building blocks of this entire chapter. In fact, how I find all the other areas is basically using this idea. Now, in postulate 24, it's the area of a square. Basically, I don't actually have a way to justify what area is, except for we are going to define it as the area for a square is side times side. And that's how we pretty much define all area, is that it is a length times a width, and that surface, that space that we're looking at, is going to be our area. So, the area of a square postulate, the area of a square is equal to, is the square of the length of the side. So if I had a square that is 8 by 8, the area would be, well, side squared, or 8 squared, so the area would be 64 units squared. And that's what I get. The next idea is something, again, that I can't really justify, but it's something that we accept to be true because, well, it kind of makes sense. If 2 polygons are congruent, then they have the same area. Well, congruent means same size, same shape. Whoa, if they're the same size and they're the same exact shape, they should have everything else be the same. Like their area, their volume, anything else that I talk about those 2 shapes, if they're congruent, it means the same. So, in this case, we're going to allow that if 2 polygons are congruent, then they have to have the same area. The last postulate is the area addition postulate. Maybe I will be given a difficult region, like for instance the one on the right here, that L shape area. And I say, hey, find this area. Well, the way that we can do this is we can break it down into parts and then find the area of each of those parts. If I would look at the picture that I have, let's say this one here. Depending on what I'm given, I could cut this into 2 rectangles. Maybe I'm going to cut it into 3 squares. I don't know what I'm going to cut it into, but I could take the area of this part here, the area of this part here, and the area of this part here, and that will be the area total that I started with, if I add all 3 of those together. So, you can find the area by dividing the parts and adding it together. So the 3 new postulates: area of a square is side squared. Area of congruent shapes is going to be the same. And if I have a difficult shape, I can break it up into smaller, easier to handle regions and add up those areas together. Let's look at an example. We are actually going to look at the shape here. And we are going to break it up, or sorry, I don't know, but I think we're going to probably use 3 of those, maybe all, we're going to use at least 1 or 2, maybe all 3 of those postulates that we just went over. So if I ask you to find the area of the shape, well, all I know is how to find the area of a square, and this shape is definitely not a square. And when I look at this, yeah, I didn't draw in right angles, but there are right angles all over the place in this. Well, if it's too complicated of a shape to do as is, break it into shapes I know how to do. What if I drew a line here that was perpendicular to the bottom? Well, it would also be perpendicular here, and that is a square. So I can find the area of that. What if I broke this part here into the same thing? Well, that's another square. Well, if this whole thing was 10, then this part would be 5 because the part across is 5, which means this part here is 5. If this whole thing is 10 and this part here is 5, well, this part here has to be 5 because it's a square, so this part here has to be 5. And look, I have 3 squares here. And they're all 5 by 5. Well, the area of an individual square here is going to be the side squared. So the area is 5 squared, or the area of one of these is 25 units squared. Now, this is a 5 by 5 square. This is a 5 by 5 square. This is a 5 by 5 square. Wait, so those shapes must be congruent because they're the same size and same shape. So all 3 squares have the same area. I have 3 squares with area of 25 units, so the area of my shape, area total, has to be 25 times 3 or 25 plus 25 plus 25. Either way, I have to account for it 3 times, so it's 75 units squared. And that's the area total of this shape. So, when you get a tough shape, and you don't know how to find the area of it, one step, possibly divide it into shapes that are easier. Then, if you know how to find the area of an individual shape, find it. And then after that, if there's any shapes that are exactly the same, congruent, that area that you just found applies to that shape also. So we actually used all 3 in our first example here. And also, you have been seeing something. Unit squared. If I do not give you units and I'm asking for area or perimeter, please add the word units or unit squared appropriately. If it's area, unit squared. If it's perimeter, just units. Those 3 postulates are still there. But using this idea, we could actually find the area of a rectangle. We can find the area of a parallelogram. We can find the area of a triangle. And that's what the next 3 theorems are, is just giving us 3 new tools to find the area. So, it might not be a bad idea to write down somewhere all the formulas. Alright, first theorem, the area of a rectangle is the product of its base and height. So basically, area equals base times height. This is probably one that you know, and it's probably one that you're pretty confident about. If I want to find the area of the whiteboard, I would take the length of the board, or the base of the board, times it by, or multiply it by, its height. And that would be the area of the whiteboard. Now, there's something actually kind of neat about theorem 11.2. When we look at a parallelogram, it actually has the same exact formula as the area for a rectangle. Area equals base times height. Well, here's the idea. If I have a parallelogram, and this is my base, and dot, 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 this is my height. Well, I know that the height has to be a right angle here, right angle here. And these sides are parallel, and these sides are parallel. Well, what would happen if I literally cut this board right here, cut out that triangle, and then I put that triangle right over there? Well, it would just so happen that that triangle would fit perfectly, and this would form a rectangle. A little bit of a justification is in here. If I take the triangle there, that's on the left side that you can see, and I were to shift it over like that, that connection right there, if I would slide it up into the slot, would fulfill it to be a rectangle. That left part of the triangle, where it slid from originally, where it slid from over here, that part would be gone because I actually moved it, and that other part would slide in, it'd be a rectangle. So that's why the area of a parallelogram is the same as a rectangle. It's because I essentially cut that triangle, take that area, move it to another spot, it's a rectangle. And the last new formula for today is the area of a triangle. It's still base times height, but it's half. And here's kind of the justification why. If I had a triangle, let's just say a right triangle like this one. If I did base times height, well, that would be the area of my rectangle here. Wait, so if base times height is the area of my rectangle, and this is a congruent triangle. This angle is congruent to this one. This angle is congruent to this angle. That angle is congruent to that angle, and I have a side matching up. There's no way I can do like angle, side, angle, 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 side to say that those two triangles are congruent. These two triangles have to have the same area. but the area of the rectangle is base times height. So if this triangle and this triangle add up to be base times height, well, each triangle then would be half of base times height. So the area equation for a triangle is 1/2 base times height. You need to know all three of these. Technically all four, with the square up there. And this is just justification for all of these. If you look side times side in a square, you're multiplying where there's a right angle. Base times height, there's a right angle. Base times height, there's a right angle. Base times height, there's a right angle. Whenever you find area, you have to multiply numbers that are at a right angle. If you don't multiply numbers that are at a right angle, you're not finding the area, you're finding something else. You can only find area by multiplying numbers that are perpendicular to each other. So, here's a quick example. Find the area of each of these shapes. Alright, here's each of my shapes. Well, the first thing I have to do is basically match up my formula to my shape. Because I'm looking for the area, I know the equation for each of these. Well, this is a triangle, so the equation I'm going to use to find its area is 1/2 base times height. The base here is 7, the height is 4, so the area is going to equal 1/2 7 times 4. Now, 1/2, 7, and 4 are all multiplying. Order doesn't matter. I can do 1/2 times 4 first. I can do 4 times 7 first. It honestly doesn't matter. I think I'm going to do 7 times 4 first. I get 28. Half of 28 is 14. And because it's my final answer, units squared. Go ahead and try the next two by applying it to the correct formula. Area for a parallelogram is base times height. So area equals base times height. Area is equal to, well, the base is 10. The height is 5. So I just do 10 times 5, or 50 units squared. The next one's a rectangle. Area rectangle is base times height. Area equals base times height. Area equals the base, 5, and the height, 8. Multiply 5 by 8, you get 40 units squared. And there we go. That's how you find the area of shapes. Basically, match up the formula, identify the base and the height, plug it in, and solve. Now, this is not the only type of question I might ask. I might ask for the reverse type. Now I'm not looking for the area. I already know the area, but I want to find the unknown variable. I want to find something I don't know. I am going to end up using the same diagrams for each of these. However, the numbers are going to change. At least most likely. If they stayed the same, that would make it way too easy. Alright, so in each of these cases, what I'm looking for is I'm trying to find the unknown variable. But again, I'm given area in each case, so I know I'm probably going to be using the area equations. If they would have given me a perimeter, I would have used perimeter equations. However, area, so I'm probably going to use the area. That's a triangle. Area of a triangle is 1/2 base times height. Now I look. A is, I actually have a number. 28 feet squared. Equals 1/2 base. 7 feet. And the height is y. The only unknown I have is y. So basically I'm going to solve for y. Now my first step here would probably be to get rid of the fractions. So I'm going to multiply both sides by 2. 2 times 28 is 56 feet squared. 2 times 1/2 cancels out. I get 7 feet times y. Divide both sides by 7 feet, and I'll get 8 feet. Feet squared divided by feet is just feet. And there we go. Parallelogram, given area. Write down that equation. Area equals base times height for a parallelogram. The area is 306 centimeters squared. The base is 18 centimeters. The height is z. Oh, I'm trying to find z. Oh, the only thing I have to do here is get rid of 18 centimeters. So instead of multiplying by z, I'm going to divide both sides by 18 centimeters. And if you can do this one off the top of your head, great. However, if you can't, calculator time. I believe you end up getting 17 centimeters. The next one, rectangle. Well, the area for rectangle is A equals BH, base times height. I have area, 276 inches squared, equals base, x, times the height, 12 inches. I look again. Well, I'm trying to solve for x, so solve for it means get x by itself, divide both sides by 12. 276 divided by 12, well, that ends up being 3 inches, so 23 inches. And that's all this is. Basically, you should be able to find the information using the equation, plugging it in, and solving for your unknown, whether it's the area, whether it's the side length, whatever it is. Now, one of the last few examples we have, which, at least for this section, is now going to apply this and the ideas we started with. It says solve for the area of the polygon. So all I'm looking for is the area of this polygon. So the first thing we have to do is draw it and figure out which equation lines up with it. I look at my shape. Based on this information, it's a trapezoid. Because this line and this line have to be parallel because they're both perpendicular to this side. I don't have that equation yet. So this shape, we might say, oh, well, I don't have the equation, I guess I'm done, I'll just leave it for later. But that's not a good choice. Because I have a tool in my back pocket still that I could use. This is a shape I don't know how to deal with. But what if I cut it at a convenient spot? Let's say put a dotted line right there. That's perpendicular to the bottom, perpendicular to the top, which means it forms a right angle. Whoa. This is a rectangle. That means this side and this side is congruent, this side and this side is congruent. So this side right here is 15 centimeters. And this part is 10 centimeters. Hold on, if this part's 10 centimeters and the full length is 20, that means this over here is 10 centimeters. Oh, I see how to do this now. I have a rectangle and I have a right triangle. To find the area here, I'm going to find the area of the rectangle. I'm going to add it to the area of the triangle. And that's going to be the area total that I'm looking for. So, the area of the rectangle. It's going to be the base of the rectangle. Base of the rectangle times the height. Base is 10, height is 15. So base times height, 10 centimeters times 15 centimeters. Plus the area of the triangle. Area of a triangle is 1/2 base times height of the triangle. Of the triangle, the base is 10 centimeters, and the height is 15 centimeters. And that's going to equal the answer I'm looking for, the area total. Oh wait, this is now just a solve. Plug in what my numbers are, simplify what I have, and I should be good to go. 10 times 15, 150 centimeters squared. 10 times 15, 150 times 1/2, 75 centimeters squared. And at this point, it's just a simple addition of 75 and 150. Go ahead and use a calculator. However, you should be able to relatively do this without one. 225 centimeters squared is the area total. So, don't just throw in the towel because I don't have a formula for the shape yet. Look at how you can break it down. That's a strategy that's postulate 26 that allows me to do this. Alright, I can break it down into shapes I know how to do, and the areas combined will be the area that I'm looking for. Alright, now, I haven't done anything with perimeter yet. But, if I ask for perimeter, or if I ask for area, we have to know the difference. Perimeter is the total length around an object. Or an object, sorry. So the perimeter is just a measurement around the polygon. So if I took a rectangle like the board here, it'd be the bottom of the board, the left side of the board, the top of the board, and the right side of the board all added together. That's the perimeter. The area would be the bottom of the board, the base, times the right side of the board, the height. That'd be the area. So one's an addition, essentially, of all the sides. The other is a multiplication across the right angle that talks about or discusses or looks at a numerical quantity for the surface of my shape. The units of perimeter is length. The units for area is length by length or length squared. So like meter squared, meter by meter, so on and so forth. Now, when to know to use perimeter in a word problem. Use to find the amount of fencing needed, the frame of an object, anything that is around the edge of the object. That's the key that you're looking for perimeter, or you have perimeter, or that's what you're going to use. Also, its units are singular. It's not going to be like meters squared or meters cubed. It's just going to be meters. That's a clue that it's perimeter. Now, if it's area, you're trying to find the amount of paint needed to paint something. You're trying to find the amount of sand, seed needed for a field, the sand in a play box. You know, something where you're putting stuff into a space and you need to figure out how much space you need to fill. So, let's do a few examples of this. I might just simply ask, find the perimeter and area of the polygon. Go ahead and try these on your own real quick. Let's say 2 minutes. Alright, the first two are up here. Now, perimeter. Let's do that one first for the first one. That's just adding up all the side lengths. So that would be perimeter equals 17 plus 10 plus 21, because those are the three side lengths. 17, 10, and 21 are the side lengths. So the perimeter would end up being whatever all three of those added together are, or better known as 48 units. Singular. If you set up the area equation right, you got this. Area equals 1/2 21 times 8. And then if you did your work correctly, you would have got 84 units squared. I forgot squared. The next one over here. This is the setup for perimeter. 20 plus 30 plus 20 plus 30, because the opposite sides in a parallelogram are congruent. So just add them all together. And if done correctly, you got 100 units. The area for number 2 is base times height. So 30, the base, times the height, 17. And if done correctly, in your multiplication step, you should have 510 units squared. So that's how to do the first two. I don't think there would have been much issue. We should be good to go. I got another one to do real quickly here. Alright, so when I look at number 3, right here, 5 and 13. Wait, to find perimeter, I need all three sides. I can find perimeter until I know this length right here. Oh wait, this is the right triangle. I know 2 of the sides, I'm looking for a third. Huge clue for Pythagorean's theorem. 5 squared plus x squared equals 13 squared. If you do not know how I got Pythagorean's theorem, Chapter 7, Section 2, review it. Or Section 1, review it. 25 plus x squared equals 169. Subtract 25 from both sides, x squared equals 144. Square root both sides, x equals plus or minus 12. However, the negative answer doesn't make sense because length can't be negative. So now I have 12. Now the perimeter and area you should be able to find relatively quickly. Go ahead and try it. This is your setup for perimeter. It should be, in the end, it should be 30 units. And for area, it's 1/2 base times height. So 1/2, 5 times 12. 5 times 12 is 60, so 1/2 is 60. My answer is 30 units squared. And there I go. That's what we have. This is how you find area. This is how you find perimeter. That is all I have for you today. Make sure you keep a list somewhere where this will be easy for you to reference. There's going to be quite a few formulas. We're only through the first section, And this is how many formulas we've got. Whew, brutal. There's quite a few. So you're going to have to know when to pull these and when to use them. And if you label like triangle, parallelogram, rectangle, square, you should be able to identify when to use it pretty easily. Well, that's all I have for you today. Till next time.